In this video, we're going to learn about long division and synthetic division with polynomials. So up until this point, whenever we've divided polynomials, we've always had a polynomial being divided by a monomial. So like 2 or 3 terms or more being divided by just one term. If we look at example 1, we can see that we are now dividing by 2 terms. And to do this, we're going to learn how to do it using long division, just like how you did in elementary school. But now we will have letters involved. So example 1 says divide 2x cubed plus 4x squared plus 5 by x minus 3 using long division. So part A says write the quotient in long division format with the polynomials written in standard form. Remember to include terms with a coefficient of 0. What this means is that if you are missing a term, like if we look at our equation that we have, 2x cubed plus 4x squared plus 5, this is in standard form, but we're missing an x term here. And so we're going to have to put a 0 in as a coefficient of x as a placeholder, that when we do our division, all of our like terms line up. So let me show you what I mean by that. So our right here we have 2x cubed plus, let me give myself a little bit more room. So I'm going to have 2x cubed plus 4x squared. And then I'm missing that x term. So I'm going to write plus 0x plus 5. And again, the reason why we're doing that is so that when we go ahead and start multiplying and subtracting, all of our terms will line up correctly. And then we are dividing by x minus 3. So x minus 3 is going to go on the outside of my division symbol here. Just like how you did with long division with numbers, you do the same exact process when you have polynomials. So I'm going to take my first term, 2x cubed, and I'm going to divide it by x. 2x cubed divided by x is 2x squared. This is the term that's going to go on top of my division bar up here. And you always want to line everything up, right? So 2x squared is going to go right here because it's going to be above the other squared term. So I always like to line everything up. Now that we know this right here, 2x squared, we're going to take this term and we're going to multiply it by everything on the outside. So 2x squared times x is 2x cubed. And then 2x squared times negative 3 is negative 6x squared. Notice how I've lined up my x cubed terms together, and I've also lined up my x squares terms. This is so that my like terms are on top of each other, making it nice and easy for me when I go to subtract. So I'm going to go ahead and subtract these two things. And one way that you can think about it is that you're going to draw your line and then you're going to change your sign because you're subtracting. So this positive 2x cubed would become a negative 2x cubed, and this negative 2x squared would become a positive 6x squared. And so again, this is just because I have to distribute that negative sign. 2x cubed minus 2x cubed is 0, so those cancel. 4x squared plus 6x squared is 10x squared. And so now I want to start this process again, but before I do that, I need to bring down the next term. So I'm going to bring down that 0x. And now we're going to start that process over again. I'm going to take 10x squared, and I'm going to divide it by x. 10x squared divided by x is just 10x. So I'm going to write plus 10x. 10x times x is 10x squared. And 10x times negative 3 is negative 30x. So now I need to subtract. So I'm going to draw my line and change my signs. 10x squared minus 10x squared is 0. 0x plus 30x is 30x. You okay, Roscoe? Next, I'm going to bring down the 5, so plus 5. And we're going to do this process one more time. 30x divided by x is 30. So I'm going to have plus 30 on top. Again, notice how my constants are lined up, my x's are lined up, and my x squares are lined up. So 30 times x is 30x, and 30 times negative 3 is negative 90. I'm going to draw my line and change my signs. 30x minus 30x is 0. 5 plus 90 is 95. There is nothing left to bring down, so 95 is my remainder. Part B says write the quotient. The last term of the quotient is the remainder of the fraction. Or is the remainder in fraction form. I need to read better. So our quotient is our answer, which is up here. So we have 2x squared plus 10x plus 30 plus our remainder, which is 95 over x minus 3. This is always how you write a remainder. You take whatever your remainder is and you put it over what you're dividing by. So this entire thing is our answer. Let's try another example. So on example 2, it says divide 2x cubed minus 10x squared plus x minus 5 by x minus 5 using long division, and state if the binomial is a factor of a polynomial. The binomial meaning x minus 5. This will be a factor if the remainder is 0. Because if the remainder is 0, then it goes in evenly, meaning that it is a factor of that polynomial. So let's see. So inside, I'm going to have 2x cubed minus 10x squared plus x minus 5. In this polynomial, I'm not missing any terms. My exponents go 3, 2, 1, and 0. So I'm not missing anything. So I do not have to have 0 as a placeholder here. I am dividing by x minus 5. So 2x cubed divided by x is 2x squared. Again, I'm going to put that 2x squared directly above my x squared term. You always want all of your like terms to line up. Just like how you would have a 100s spot in the 100s place, the 10s in the 10s place, and the 1s in the 1s place when you were doing this in elementary school. So 2x squared times x is 2x cubed. 2x squared times negative 5 is negative 10x squared. I am going to draw my line and change my signs. Again, the reason why I can do that is because I'm subtracting. When you're subtracting, you distribute that negative, making this negative and this positive, because a negative times a negative is a positive. So let's go ahead and combine like terms now. 2x cubed minus 2x cubed is 0. Negative 10x squared plus 10x squared is 0. When this happens, when both terms eliminate, go ahead and bring down the next two terms. So instead of just bringing down one term, we're bringing down both because both of these terms eliminated. We're going to do the same process over again. X divided by x is 1. So plus 1. 1 times x is x. And 1 times negative 5 is negative 5. I am going to draw my line and change my signs. X minus x is 0. Negative 5 plus 5 is 0. So my answer is my quotient, which is 2x squared plus 1. And then we also want to know if this binomial is a factor of the polynomial. The answer is yes, it is a factor. And again, it's a factor when the remainder is 0. If the remainder is not 0, then it's not a factor because it didn't go in evenly. So this is polynomial long division. But there is a faster and easier way. The faster and easier way is through synthetic division. So let's look at example 3. So with this example, we have divide 3x cubed plus 14x squared minus x plus 20 by x plus 5 using synthetic division. So synthetic division is when you just focus on the coefficients. So if you look here, my coefficients are 3, 14, -1, and 20. And you'll see that those numbers are right here in that order. If you were missing a term, you would use 0 as a placeholder, just like how we did on example 1. But we are not missing a term here, so we take each one of those coefficients in standard form and write them down. So step 1 is write the coefficients of the polynomial in the top row. That's this right here. Step 2 is to write the divisor in the form of x minus a. So x plus 5 turns into x minus -5 because a negative times a negative would make a positive. So if it's in the form x minus a, then here a is -5. Basically, all you need to remember is whatever this number is, you're using the opposite sign. So instead of +5, we're going to use -5. Step 3, write the value of a in the upper left-hand corner. That's what I just did. Step 4, bring down the first coefficient. So you always bring down that first one. Multiply by a and place the result in the next coefficient and then add. Continue until the last column. So what we're going to do is -5 times 3. -5 times 3 is -15. So that goes in that next spot. And now we're going to add these two together. What's 14 plus -15? -1. And then we're going to do that process again. -5 times -1 is +5. And then we're going to add these together. -1 plus 5 is 4. -5 times 4 is -20. 20 plus -20 is 0. Whatever is left here is the remainder. So whatever this last box is your remainder. So here we do not have a remainder, so that is a good thing. Step 5 is to write your quotient. So it is always, it always decreases by a degree. So let's do this. Always decreases in degree by 1. So what I mean by that is if you look at the polynomial we started with, it was x cubed. So this one, this first one, this 3, is the coefficient of x squared. And this is the coefficient of x to the first. And this is the coefficient of x to the 0th power. So my answer is going to be 3x squared minus 1x, or just x, plus 4. This is your answer. And again, you get this answer because 3 times x squared is 3x squared. -1 times x to the first is -x. And anything raised to the 0th power is 1. 4 times 1 is 4. if you had a remainder here, then you would have plus your remainder over x plus 5. But our remainder is 0, so this is your answer. Let's look at example 4. It says divide the following using synthetic division, and then state if the given binomial is a factor of the given polynomial. Again, this will happen when the remainder is 0. So with this one, our remainder was 0, so x plus 5 is a factor of x cubed plus 14x squared minus x plus 20. So let's look at example 4. First, always check to make sure this is in standard form, and it is. So my numbers out in front here are 4, 5, 2, and 16. I am not missing any terms. If I was missing a term, I would put a 0 in for that, but we're not missing anything, so we're good. My divisor is x plus 2, so again, you just change that sign, so it's going to be negative 2. You always bring down your first term. Negative 2 times 4 is negative 8. 5 plus negative 8 is negative 3. Negative 2 times negative 3 is positive 6. 2 plus 6 is 8. Negative 2 times 8 is negative 16. 16 plus negative 16 is 0. Your last term is always your remainder. My remainder is 0, so yes, this is a factor because it went in evenly. Oops. And then we want to write our quotient. So we started with x cubed, so this is going to be x squared, x to the first, and x to the 0th power. So my quotient is going to be 4x squared minus 3x plus 8. This is my answer. Why don't you go ahead and pause the video and try example 5 on your own, and then we'll meet back up here in a second. So the first thing that I would look at with example 5 is you want to make sure that your polynomial is written in standard form, and it is. But when I look at this, I have an exponent of 3, and then here I have an exponent of 1. I am missing that squared term, so I know right away that I want to add a 0x squared in there. That way everything will line up when we go to multiply and divide. So my coefficients are going to be 1, and then 0 for that missing x squared term, negative 13, and 7. We're dividing by x plus 4, so I just need to change that sign to a negative. And so we're going to bring down the first term. Negative 4 times 1 is negative 4. 0 plus negative 4 is negative 4. Negative 4 times negative 4 is positive 16. Negative 13 plus 16 is 3. Negative 4 times 3 is negative 12. 7 plus negative 12 is negative 5. Negative 5 is our remainder. Our remainder is not 0, so no, it is not a factor because our remainder is not 0. I started with x cubed, so this is going to be the coefficient of x squared, x to the first, and x to the 0th power. Remember, this is your remainder. So my answer is going to be 1x squared, so that's just x squared, minus 4x plus 3. And then you want to include your remainder, so minus 5. And remember, you always take your remainder and put it over your divisor. So that's going to be divided by x plus 4. This is my answer.